This question, in some ways, is quite nice because I think everyone can have a go at it. It's not too bad to understand compared to other question 25s. What I would say, however, is like the proof is like next level compared to a lot of question 25. So that is kind of more accessible and it's kind of not if you want to show the full proof. And I'm going to talk about both aspects. So this is saying we're trying to fill the grid with dominoes. And here I am drawing some. And we're trying to leave as many holes as we can. Now, let's look at what if we're trying to leave as few holes, just first of all, just to illustrate the idea of what's going on. And we're always going to get at least one. Okay, we can't avoid that. Now, something that this brings about is actually there's always going to be an odd number of holes. So if I kind of just rearrange these bottom ones in a slightly different way, okay, I could put it there, and then one here, and now I'm going to get three holes. But because I've got an odd number of squares that I'm covering, and basically each domino is of area 2, then I'm going to do 25 times some multiple of 2. There will be an odd number of holes. If you can realize that, you can actually straight away rule out 6 and 8. There's no way that could be true. I gotta be honest, I didn't spot that when I did it. I kind of muddled my way through and got to what I thought was the answer and went with it, and it was correct. Which, sometimes when you're under time pressure, that's what you have to do. But we're just trying to justify it here. If you can spot that, then we're already. Oh, sorry, I'm four. We're already down to just two possibilities, in fact. So as long as we can show, well, we can. If we can show that we can get 7, then we're sorted. So this time I'm going to do a construction trying to leave as many holes as possible. I'm going to try and leave one there, so I'm going to cover up there. And I'll try and leave one there, so I could maybe go down like that, and then one there. And if I go across here, I can leave one there. It's quite a little effective strategy. Leave one there, and then maybe I'll go here, and then I have to put one there. But what I've managed to do is create 1, 2, 3, 4, 5, 6, 7. So 7 is definitely possible. We know that 8 is not possible because of my argument earlier. We haven't shown that 9 is not possible, but in the context of this competition, it's definitely enough. 7 is the answer. Now, you might be wondering, how do we know that 9 is not possible? It's an odd number, so it's not eliminated by that, that idea I had at the start. But this is a much harder problem in the realms of JMO, and you might want to look into some of those problems, the B questions at the end where you have to show all your reasoning. And this is how we're going to do it. We're going to take our board and we're going to turn it into a chessboard, essentially, labeling them white, then black, then white, then black, and so on, as shown. This is often helpful when you're trying to prove placement questions. And I'm going to assume that 9 is possible. Quite a deep idea is we're now going to use. We're going to assume that 9 is possible, and we're going to get a contradiction. What I mean is, if we could assume that 9 is possible and then find that 1 is equal to 0, we know that 1 is not equal to 0, so it must have been that our original assumption was incorrect. This is called proof by contradiction. Assume the opposite of what you want to prove, get a contradiction, so the original thing that 9 is not possible must in fact be true. Now, when we place the tiles, they always cover a white and a black. So after we've placed our, well, there's 9 left. So after we've placed our, it's going to be our 8 tiles, so 16 of them, then we're going to have covered 8 white squares and 8 black squares, which means there's going to be 5 white holes left over. Holes are where there's going to be gaps, basically, and 4 black. The first part of this proof, and this is not at all obvious, I don't think, is to show that the very center square is going to be a hole. Because if it's not, and we're trying to fit in 9 holes, then we must be that we could put 3 in one of the rectangles. So let's say we put it in the bottom right. I mean, this is there's rotational symmetry to this problem. So if I put in 3, Okay, well, one thing is that the holes can never be adjacent to one another because if they are, you could just actually fill it with a domino. So it must be that the holes are the same color. But the thing is, I then can't place any tiles. I can't place a tile in here because it's two by one. And if I make them white instead, then again the same problem occurs. So I've almost done a little mini proof by contradiction here. I just basically can't fit three holes in one of these 3 by 2 squares. So the middle must be a hole. Okay, I've not written that down, but I've explained verbally. You'd be expected in the JMO, by the way, to like make an argument for that and write it down. Now, as I said before, holes can never be adjacent, so it must be that tiles are occupied in these shaded squares here. And we're actually nearly there now, believe it or not, because we've said that there must be 4 black holes. However, if I try to fill one here, then remember, I'm not allowed to use any adjacent squares because then I could fill it with a tile. So this can't be a hole, this can't be a hole, and this can't be a hole, which means that that one must be. But that's not possible because then I can't fit a tile in. So basically, once we've got this set up with a hole in the middle and these shaded, it is not possible to construct any black squares with holes in because as soon as you do, you can't actually fit the tiles in. And therefore, this is a contradiction. You cannot fit these holes, and this assumption that 9 is possible is incorrect. And therefore, it must be less than 9. We've shown that it's possible for 7, and therefore that is the largest possible number of squares. Okay, well done for sticking to the end of that. Do have a look at the official solutions for their explanation of it. They maybe go into a little bit more depth about some of these ideas. I've tried to summarize it and not overcomplicate it because theirs is like 2 pages, but I hope I've got the main idea across. Well done.